Good afternoon, class. Today we're going to be learning solving linear systems by substitution 5.21.
Thank you, Will.
Yep.
All right, so a couple review questions. What is a system? What is a system of equations? Anyone remember?
That's what we did yesterday, this is what we did in the warm-up today.
Josiah?
Is it the linear equations where you plug in the x and y?
All right, so you have an equation with x and it has to have a y in it. And how many of them do you have? Joe? Two. Two or more, yes. So two or more equations, usually with an x and a y, and we have to solve for two variables.
And again, you guys don't have to write this down, that's taken directly from what we copied down yesterday. Just so you guys remember what a system is.
How did we solve systems yesterday and in the warm-up? What method? We didn't do substitution. We're going to look at that today. What method did we use yesterday? Yeah?
We put them on the graph.
We graphed them. Exactly. We did graphing. Now, for many reasons, graphing isn't the best way to do this. Okay? It's something we have to go over, but there's much better ways, including the one we're going to show you today. Anybody tell me why graphing can be difficult? What makes graphing time-consuming? Yep.
Oh, time?
Yeah, what makes it difficult?
Because how about it's not exact?
That's a really good answer. What if it's not exact? What if you have one line that crosses at like 1.6 or 1.7? You can't tell, right? So unless you use a computer to graph it by hand, decimals are awful. Another thing that makes it kind of time consuming, you got to have a ruler. You got to draw things accurately. You need graph paper. A lot of things you need make it time consuming for graphing. Okay? So we're going to look at an approach today that it doesn't matter if your answers are decimals. Decimals, not decimals, you can use a calculator. It's not any more or less difficult. Graphing, very difficult if it's decimals. Okay? So we'll kind of get away from graphing. All right. So now I think you're at the point on your sheet just about where you're going to write some stuff.
Okay.
So another way to solve systems is with substitution. Okay? There's actually, I can think of four ways. There's graphing, there's substitution, there's what we call elimination, and then there's also matrices. So there's a lot of ways to solve systems. Okay, what we're going to try to do is break it down into different cases for you. Cases where you have to rearrange stuff, in cases where it's good to go. You can just use it the way it is. Nothing to rearrange.
Yeah, so guys, with that, so the first one is situation one, you're going to write this down, but there's no rearranging. What that means is x or y is already going to be isolated. That means it'll be like y equals 2x plus 5. X equals y minus 7. All right, that's an example. This is an example of y being isolated. That's an example of x being isolated. Isolated means it's by itself on the left-hand side of the equal sign, and there's no number attached to it. That's when it's isolated. And in some cases, guys, we also put on the left side in 1. Sometimes we may give you. We'll do a couple examples today where the variable is isolated in both equations. It might be y equals something in one, y equals something else in another. But most times we're going to give you a system where x or y is already isolated for today. So that means you don't have to move anything around. Like we did with like slope-intercept form, you had to like, add x to one side to get y by itself, sometimes divide by the number with y to get it by itself. Nothing like that today. Right? It's already going to be isolated.
So if it's already isolated, then we can go right to step one. You're going to find the equation that already has one of the variables by itself. If they both have variables by themselves, it's a little different. But if one of them is by itself, you're going to do what it says right here. Find the equation that has the variable isolated by itself. And you're going to take everything that's after the equal sign. We're going to put parentheses around it. Okay, all we're really doing is putting parentheses to kind of block off the important information like this. So what we're telling you there is 2x plus 5, that's important. You're going to do something with it in the next step. Y minus 7, that's important. You're going to take and do something with that in the next step.
And remember, if the variable's by itself, that's fine. But there can't be anything else around it. Alright? Chances are it's going to be on that left-hand side of the equal sign. By itself with no number attached.
Okay, so I like to label my equations 1 and 2 just so I can reference it easier.
You guys have that equation on your notes.
Which equation, 1 or 2, already has the variable by itself? Yep.
1.
Equation 1. Okay. What variable is by itself?
Y.
Y is all alone. That's perfect.
Oh, wait a minute, guys. Look at the bottom here. We got y by itself.
No,
Okay. Why is it? Joe, tell me why it's not by itself.
By itself on the other side of the equal sign.
What else is with it?
The 6,
It's negative 6x. So understand the difference, right? This may be by itself, but it has the negative 6x with it. Right? Don't get confused by that.
Okay, so y is by itself in the top, and now it says put parentheses around the information after the equal sign. So the reason we did that is because this negative 3x plus 5 is important. Something's going to happen with that in the next step. Okay, questions on that step? So we haven't really done any math yet.
No.
Okay. Now we're going to do some math. So we're going to put parentheses around the variable that's isolated in the other equation and plug in. So in equation 1, what variable was by itself?
Y.
Y. I want you to put parentheses.
So I'm going to say, you can just scroll down a little bit more. I think we have that example right below it. There we go. Let's go right through step by step.
So I want to put parentheses around the Y in the other equation.
You got something to read?
Wait, I don't know. Why? What do you put?
No, not at that point yet. Not at that point yet. We'll get there. So again, all you're doing is looking for what's isolated. This one is isolated. We put parentheses around it, and then we're matching it up. So whatever's by itself here, put parentheses around it down there. That's what we're doing.
So now after it says put parentheses around the variable in the other equation, okay, if we call that equation 2, the next step says plug in the information that already has parentheses around it. So look at this example right here. It says y equals negative 3x plus 5. We are going to take and plug that information in right there. That's a y. The top equation tells us what y equals. Y is negative 3x plus 5. So everywhere you have a y in the second equation, you can change it to negative 3x plus 5.
Okay, that makes sense.
Kind of like yesterday where we gave you the coordinate, right? It was an XY coordinate, and we said wherever we saw those letters, we would put those numbers. The only thing now is we just have a few more, it's hard to think of it, but we have a few more terms. That's all.
That's a big equation.
Mr. Hager,
Yes.
can you go up real quick? I really like 2 more words.
So now we're rewriting it. It says plug in the information that has parentheses around it. So now, what did I just say we're going to change this y to?
Negative
3x
3x plus 5.
Right, you're always going to change it with the thing that's right up above. Negative 3x plus 5. Now, if you look at that equation that I just wrote, how many different letters are in it now?
No, just one. 2.
Just one.
What?
X, X. Those are the same letters.
No.
There's two
There's no Y.
different numbers with X attached, but there's only one letter, just X.
That's the point of substitution. We've taken an equation that had X's and Y's in it, and now we've turned it into an equation with just X's.
So you can put them together.
So now we can combine like terms, we can put things together, and we're going to be able to figure out what X is in a second. So now, solve that equation right there. And after you solve it, you will now know one of your answers. You will know X.
Wow.
But you still
I
have to
go
find,
back and do it for y.
you still have to find y, but once you get x, y is very easy.
So, so now you're at step 3. So all Mr. Hager's going to do now is just take, he's just going to rewrite that equation that he created for step 2 for step 3. Step 1, identify, right? Which one's isolated? Step 2, take what's isolated, plug it in. Step 3, now we're going to actually solve.
Okay. So now we have a negative 6x and a positive 3x. Are those like terms?
Yeah.
Yeah. What's negative 6x plus 3x?
Oh, I thought that was negative 3x. Well, you would subtract, so it'd be.
You're right. It should be a negative. Thank you.
Oh. Well, then you put them together, so it'd be 9x.
Careful.
Negative 9.
Negative 9x.
Wow.
So negative 6x plus negative 3x is negative 9x. For now, let's just copy down the plus 5. Let's just copy down the negative 1.
So guys, when we get to this point,
Wait, I got stuck.
the first thing we want to look at, see what we can do is distribute. But there's nothing outside, there's no number outside the parentheses that's not going to happen in this. Sometimes it will. It doesn't always. So you may have to distribute, you may not. What did we just do in that last step? What did we just do in that last step right there to get the negative 9x?
We multiplied.
No.
No, you put them together.
Yeah, so next step, like we just did, add or subtract. I'm sorry, I won't put that.
Oh.
Combine like terms.
I'm just going to put CLT,
Yeah.
combine like terms. Great mistake.
Now, goal is to still get x by itself. Who can tell me the next step to getting x by itself?
Plus 1.
But the answer would make sense.
I like doing something with the 5.
Ooh,
I'm glad you didn't say anything with the 9 yet.
Oh.
But what do we do?
Minus 5.
Sorry, what did you have?
Minus 5.
Minus 5. So what does that give me on the left side now?
Negative 9x.
Negative 9x. What does that give me on the right side?
Negative 6.
Negative 6. So what was the next step we just did?
Ooh. Wait. Divide.
Well, what did we just do right here?
Subtract.
Subtract.
So you either add or
So you either add or subtract.
Subtract. And you guys, for what we're doing with substitution, all right? It's always going to be these steps. You may not have to do all of them, but this is kind of like a checklist to follow to get you through it.
Wait, how do you know what it makes sense?
Yeah, that doesn't make sense. You can't put 6 in and 9.
Yeah.
And
Yeah.
You divide by negative 9.
you may get a fraction. You may not always. A lot of times you won't. In this case, you do,
Yeah, this is going to be a fraction.
Oh,
which is okay.
Negative 6x plus negative 3x, we combine like terms.
Plus
But
negative
there
30.
are parentheses.
That's okay.
There's
You can
still
still
the
combine
same.
like terms.
Okay.
Yep.
I mean,
You said it was.
Now, how do we get x by itself? Because that negative 9 is still there. We don't want it there. Yep, Paige.
Divide by negative 9.
Divide by negative 9. Divide by negative 9.
Negative number 3.
Negative divide by negative.
Positive.
Positive. And can you reduce 6 divided by 9? I think I heard you say something about a 3. Divide top and bottom by 3.
Wait. So it'd be 2/3.
So it would reduce to 2/3.
And guys, in most cases, you're not going to get a fraction. You very rarely would you, but you could. A lot of times you're going to get a whole number, but you may get a fraction.
So that last step, we had to divide. Sometimes you might have to multiply.
So guys, as we understand, these steps right here are always the same. Distribute if you can, combine like terms, add or subtract depending on what the sign is, and then multiply or divide. It's always the same.
Now, even though we only have one of the two answers, we've done like 90% of the work. To get the second answer, it's very easy now that we've done all this. Scroll back up for 1 second. Do you have an equation or a formula here that already has y by itself?
Yeah.
Yeah. And now you know x. What did we just get for that?
2/3.
2/3. All we have to do now is fill in what we know this is, do the arithmetic out, and then we'll know y. So now we just need a calculator, and we have to plug
So,
in.
guys, at this step, for this step, there's no real You don't have to move anything around. You don't have to like, okay, I'm gonna -5 on this side, -5 on that side, because both your terms are gonna be on the same side. So just do the math and you'll get your answer. The only time you have to move stuff around is when you're doing the first one, to solve for the first variable. For the second one, it's gonna be all set up.
Right, so I just copied down equation 1 from what we had up above. And I'm also gonna copy down my answer. X equals 2/3. Now, why didn't I just plug in 2/3 right away in the first step and find y?
Because you already solved.
Well, why didn't I just do this as the first step?
Because we didn't know what.
We didn't know.
it was.
Yeah.
Exactly, we didn't know it. You have to find it first, and then you can take this and plug it in right there.
Partly from my desk.
So, somebody remind me, what are you plugging in for x?
2/3.
2/3. So -3 times 2/3 plus what?
5.
Plus 5. Now -3 is not a fraction, but if you wanted to make it a fraction, just like this was a slope, you
Put a
could
1.
put a 1 on the bottom. Now before you add, let's reduce anything we can.
It cancels out.
It could be like
What?
-1
It'd be 2.
and 1.
-1 and 1. Yep.
So that's what Savannah did, but she said, okay, 3 goes into 3, once here, once up there. She just cross canceled, that's all. And you can multiply across as well.
Now what's -1 times 2?
-2.
-2. And then in the bottom, 1 times 1. Do I even need to put that? Just divided by
2 over
1.
1 is,
So you'd add 5, and then you get 7. And then, wait, no, it's a negative. Why is it a negative? Negative's right.
So what's -2 plus 5?
You'd have to subtract.
3. Yeah, you 5 minus 2. You can think of it as subtraction. Yeah.
Besides those stress.
And what is 3? What is that?
Negative.
Your y.
It's my y. So there's your two answers. X equals 2/3, y equals 3.
and there's one more step, Mr. Hager.
Wait.
That's how I should write it.
We're done.
Do we have to?
It depends how they ask it. Remember,
I think on the test it might show up as, the answer might show up as a coordinate.
so if you were to draw these lines, that's where they cross. 2/3, comma 3. That would be kind of hard to see. 2/3 is the decimal point 6 repeating. You're not going to be able to tell that on graph paper.
And again, guys, don't get freaked out because we got a fraction as an answer. In most cases, 85% of the time, you're going to get whole numbers as answers. In this particular case, it just worked out that we got a
Are you
fraction.
guys gonna put any fractions on the test?
I'm not
I can't say for sure.
Yeah, I don't know.
Please
Don't do that.
I mean, you can use a calculator. You don't have to do that in your head like I did. You can use a calculator. Okay. Does everybody have the 5 steps?
And number 4.
I kind of like this.
You're on
better
step
than
4?
Graham's.
So again, guys, it's when you're plugging in your information, you're just plugging in more stuff for a variable. Yesterday we just plugged in one number. We said x was 2, y was -5, whatever. We gave them to you, you plugged them in. Today we're still kind of giving them to you, but the only thing is you have to. You're just plugging in more stuff. It's weird to plug in. Now you're plugging in a variable and a number for another variable. So it's kind of weird to think that way, but we are still giving you the information you need to plug in.
Okay, so the next one, instead of kind of guiding you through it, I'm going to ask you, what's step 1? You tell me what to do.
Alright.
Okay, we'll do a couple like that, and then I think there's one we have for you guys to kind of try if we have a little time.
With some.
What's what?
By some.
Yeah, we'll walk around and help you.
Yeah.
But we're going to kind of gradually get you to that point. We're going to still do this one together.
Yes.
We're good on the 5 steps?
Yeah.
All right.
So guys, again, it's gonna be a little bit tight, but do the best you can to squeeze it in the bottom. Alright, so you don't have the system written in on your notes, just like yesterday. You need to write it in. Right, Jack? You're writing the system in.
It says like 1C, 1D, and 1E, so what do we just write that?
Right in the bottom.
I'm
Yeah.
blind.
Yeah.
Nice to
Don't mind
know.
you. So first step.
First step. Tell me the first step.
You're gonna find the isolated variable.
I'm going to find the equation with the isolated variable. Let's call it equation 1 and
Guys,
equation
we're
2.
still on the front side of the bottom, right? A couple people that are out of time with that.
Yeah.
Sorry, Savannah.
What's, go ahead, Savannah.
So the one with the isolated variable is 1.
Equation 1, I agree. So what do I do with the information after the equal sign?
You put it in parentheses.
All right. And can somebody else tell me where else I put parentheses? Ooh. X
The y.
around the Y.
What, how come the y-x?
Because it's before the equal sign.
Exactly. Whatever variable's before the equal sign is what you plug in for in the other equation.
Now, Mr. Roy just told you the next step. Can somebody go ahead and tell me what to do now?
See your bud.
Yeah?
You're gonna put the first part of the equation in the
Yep.
y in this case.
You're going to take what y equals. This equation says y equals all this stuff, and you're going to replace the y in the bottom with all that stuff.
Everything else stays exactly the same. And guys, don't forget to write what comes after what you plugged in. So in this case, don't forget to write don't forget to write that equals negative 19. Right? Don't forget to write that.
So now next to the 5, you're not going to put a y anymore. You're going to replace y with all the stuff that I'm pointing to.
So 6x minus 5.
So what's going to go right inside?
2x minus 9.
Negative 2x minus 9. Now we have to go through those 4 steps that Mr. Roy and I wrote down right there. Distribute, CLT. Okay, let's go through it. Do we have a distributive property here?
It's right next to the parentheses.
Exactly, it's right next to the
So someone
parentheses.
tell me by raising their hands, what number is going to get distributed? Sophia? Excellent. Don't forget that negative sign to the left of it goes with it. If you distributed a positive 5, you'd be wrong. You got to make sure you take the sign to the left of it.
The 6x, that's not going to change. The negative 19, that's not going to change either. What's negative 5 times negative 2x?
10x minus.
10x.
Positive or negative?
It would be
So you got to make sure, guys, when you do that part, you can't just write 10x. Write the sign too.
What about negative 5 times negative 9?
45.
Positive
45.
45. After distribute, what was the next abbreviation we wrote? CLT, combine like terms. Are there any like terms?
Yeah, 6x and 10x, so 16x. 16x plus 45 equals
10 and 45. And how'd you get 16?
Because 6 plus 10 equals 16.
6 plus 10 equals 16. Now the next step is you're adding and subtracting. Is there any adding or subtracting I can do?
Yes.
45 from each.
Do what with 45?
Each side.
Subtract it.
Yeah.
I got 60.
So then you add it.
Yeah.
And now, does anybody know what negative, if you're not sure what negative 19 minus 45 is, just do 19 plus 45 and make it negative.
9,900.
Negative 64.
64.
Last step.
Divide 16.
Divide by 16, and I heard Savannah say the answer. What is it?
-4.
X is negative 4. Okay, are we done?
No.
No, we're like 90% done.
That's like,
Oh, no,
What's the last thing?
In the equation with the y already minus.
Take the equation with the y by itself, so let me take that, y equals negative 2x minus 9.
And you plug in x.
So y equals x.
Put in the x right there. Why didn't we just fill that x in to begin with?
Because you had to.
We didn't have it, so you have to find it, and then you fill it in. So can somebody tell me what this equation will look like when I fill that in? Noah?
Y equals negative 2, parentheses, wait, what is that? Oh, negative 4. And then negative 9.
Negative 9. Yep. PEMDAS, always do multiplication first. What's negative 2 times negative 4? Positive 8.
Minus 9.
You guys never learned German?
No, I learned PEMDAS.
I learned German.
Interesting.
Mr. Hager, what's
I
German?
came
I don't
from
know.
Murdoch.
Oh,
Yeah.
Make up your own stuff.
oh grouping symbols.
Yeah.
What's 8 minus 9?
What's that?
Negative
1. Now, those are the two answers, but how did we say to write them?
Coordinates.
Coordinate. So what would the coordinate look like? So if you were to draw these two lines, where would they cross?
They would cross and
You should be able to tell me exactly where they cross.
Oh, I know where they cross.
-4, -1.
Oh, those are it? Oh.
Yeah.
That's the coordinate.
Oh,
That's
because
what.
when we went to graph, we went up and, okay. Okay.
So it's the same thing we did yesterday, except you guys are just doing it with substitution, not graphing.
Alright, so look at the next one, guys. Here's our next one. So we got y equals x minus 7, and we got y equals 9x minus 47.
can I do this on my
Alright, so I like how someone said that. This one is different than the other ones we've done. How come? What'd you say, Will?
I said, why is there both Y's?
Why is there both y's? What do you mean by that?
Why? What do you mean?
What do you mean by that? What do we call this when it's by itself like that? Both y's are.
Isolated.
Yeah. So in this equation, like we wrote in our notes at the beginning for step 1, we said that one of the variables will be isolated in one or maybe both of the equations. This is a situation where it's isolated in both. Right?
It doesn't make it harder, you actually just have more choices how you solve it.
Exactly. So basically all we're gonna do here, guys, when we have one like this, it's y equals, right? So it's almost like this y equals, it's almost like y equals y, right? What's the information that we got for the first y in the top equation, or equation 1?
X minus 7.
X minus 7. So I'm just going to write it right below it. X minus 7. That's the information it gave me for y in the first equation, right?
Put your parentheses around it, just like we did before.
Yep. And then in our other equation, Fred, what's y equal in the other equation? 9x minus 47. So I'm just showing you here, guys, that our first y, I'm just showing that this is a situation where we're just going to set them equal to each other. All right? The first y is x minus 7. The y that's isolated on the bottom is 9x minus 47.
Yes, it is. Do it exactly like we just did the other two.
So we're just gonna take this one and plug it in. I'm just trying to show you guys here visually how it works out. All right? But we can still do it the same exact. We can still do it. We can still do it the same exact way. All right? You don't have to write that down.
Oh, yeah, it does make sense.
Just do it the
So, if I was gonna write out, Connor, if I was gonna write out my equation now, what's it gonna look like? What would you say to me? We're taking this and plugging it in for y down here. What's the first thing I'm gonna write? X minus 7, perfect. We took the top equation, we took the top information it gave me for y, and plugged it in for y down here. All right, Ginny, what's gonna come after that? So we took this, put it here, x minus 7. What's gonna come after that? Okay, I like the 9x minus 47. Someone tell me by raising their hand. What's missing?
Equals.
The equal sign.
I finished.
All right. Now this one's a little bit different. What was when we get to that third step now? When we solve, what was the first thing we had to do there? We're in that third step now, and we're actually solving for our first variable, right? What's the first thing we look to see if we can do? Josiah? Distribute. Can we? Why?
Because there's nothing.
No parentheses, okay? So there's nothing like that on this one. What's the next step that we can look to see if we have to do? What do you think, Malin? What's the next? So we can't distribute. What's next?
Because minus 9x.
Okay, but what's the next thing in our order? We can't distribute, so we look to see if we can do what? Combine like terms. Can I?
Yeah.
I can?
Yeah.
Okay. What are my like terms?
You got x and 9x.
I got x and 9x. Can I just take them and add them together and get 10x?
No, you have to minus.
Exactly. You're gonna, Savannah, say what you were gonna say.
So you're gonna pick a side.
Exactly. I can't combine them. Why? How come I can't just put them together? Well,
It's an equal sign.
they're on opposite sides, right? Yeah, this equal sign's like blocking it from happening. So like Savannah said, pick something to move. Savannah, what do you want to move?
I wanna move 9 to the left.
You want to move 9 to the left?
Yeah.
Okay. You can do that. Okay. You can do that, and you're not wrong. All right.
Alright, we're gonna move x.
I would move the x. Reason being, x is smaller than 9x. I won't be dealing with negatives. For some people, they have a hard time working with negative numbers. So I would say move the smaller one. Move the x. Minus x, minus x. This will cancel out. When I do 9x minus x, what do I get? 8x. Everything else just comes down. All right, and all I'm going to do is just bring that stuff down. A negative, don't forget to bring that negative with the 7, because it's to the left of it. It has to come down. And then minus 47. All I'm doing is taking these things and bringing them down. That's all I'm doing. All right? Savannah?
So since you brought the x to the right, you're gonna take the normal numbers to the left.
Yeah. So like Savannah said, I took the number from the left and moved it to the right. Now she says, whatever number's left, where I just moved the variable to, like I just moved this x over to here, that means there's got to be something else on that side with that variable. I don't want that. So someone tell me by raising their hand, what's the number on the other side with the variable? So the variable is 8x, I know that. What else is over there with it, Josiah?
Negative 47.
Negative 47, what do I have to do?
You bring it as a plus 47.
Yeah, do the opposite operation, is add 47, and Josiah, where else am I going to add 47?
On the other side, 7.
Alright, so I'm going to add 47 over here.
And then,
Now, in this case, I got a negative 7 and a positive 47. My answer is going to be positive or negative?
positive.
Why?
Because the positive number is higher.
Exactly, it's bigger. So essentially, what am I doing for a problem? 47 minus 7. What do I get?
40 equals 8x.
40 equals 8x.
Then
And you divide by 8.
Divide by 8.
You get 5.
X equals
It's 5.
5. Nice job. Alright, so I solved my first variable. Now, what am I going to do now?
You have to solve for y.
Solve for y. But whoa, I have a choice now, because like Will told us at the beginning, y is isolated in both equations in our system. It's isolated in both. Which one, someone tell me by raising their hand. Now let's do it this way. How many people think the top equation would be better to plug x into? Me? Heck yeah.
Oh, I
Me? I said, I want to plug into the top equation.
Because y is
Anybody?
isolated.
Anybody want to plug into the bottom equation?
Oh,
No. Matt, nope. Josiah, why?
Because then you have to do like multiply.
Exactly. The top one, Mallory. Why would I pick the top one?
Because the y is not isolated.
Yeah, well, x is already by itself. There's no number attached. Like Josiah said, I'm going to have to multiply down here. I don't want to do that. Up here, I can just plug it in, no multiplication, and just do my math. All right? So I'm going to plug into the top equation. So Z, if I plug in x to the top equation, what should I write for that equation? Y equals 5 minus 7. When I do that, Z, what am I going to get? -2. Excellent.
I kind of like these.
Now, Jack, how do I write it? I don't want to leave it like this. How should I write it? Are you not sure? It's okay. Joe? Coordinates. What's the coordinate going to be, Joe? 5, comma, -2. And there's your answer.
This one was easier than the other one.
These were, again, we just wanted to show you. We wanted to show you different ways of how to do it. Miss Jacob, do we want to go to that word problem? Okay, let's do that. All right. So again, we already have the word problem set up. We already set it up yesterday. We're just going to use substitution that we learned today. We couldn't do it yesterday because the numbers were too big. We couldn't graph it because the numbers were too big. So look back at your example from yesterday, right? It was a question about, I think it was, no, I'm sorry, this was a homework question. The question we did yesterday, I think it was example 3.
Yeah.
It was about the candles, yeah, that's right, that was the homework. So the question about the candles.
That's all we go.
Where's that?
Bad scandals.
I need a lover.
We only have one.
Alright, am I good, Mr. Hager? Just gonna fix the spelling. That's alright. Alright, so now, somebody tell me, in that equation, right, in that system I should say, Fred, can you tell me from example 3 from yesterday, all you gotta do is look, do you have your notes out? That's okay. How about X? Can you tell me yesterday what the first equation was?
Oh, I saw it.
Go ahead.
4x plus 6y equals 144.
Alright, so yes. What happened there? Yeah. Did we lose the first one in this data?
It's so bad.
That's example 2.
It's okay. I do so
Oh, okay.
Okay.
Oh, what happened there?
No, we did example shuffle. Leave me alone.
Why so bad?
So what was the top one? X?
4x plus 6y equals 144.
4x plus 6y equals what? 144. That was my top equation from yesterday, right?
Yeah.
Fred, do you have your notes now?
Yes.
Can you tell me the bottom one? Or equation 2 from example 3 yesterday?
Y
Yeah.
equals 4 plus x.
Y equals 4 plus x. Does anybody disagree with that?
No, but where are you?
So now listen, on your notes from today, all right, I want to say, for example, 1e, this is example 1e. We skipped 1d, we're going to 1e, right?
1D.
On the back side of your notes, when it says, next to example 1e, it says C, example 3 from
I
yesterday.
have one.
Well, I do now. That one.
Not from yesterday's notes, from today's notes.
What? 1D, 1E.
Come on, just.
So we're on what? We're taking example 3 from yesterday and writing it in for example 3 from today. Not the whole word problem, just the system. That's all we're doing. Are people with me?
Yes.
People okay? Alright. So now, under example 1e, where it says see example 3 from yesterday, you should have this. Because all we did yesterday for example 3 was just set it up. We couldn't solve yet, right? Why couldn't we solve? What did we use yesterday?
We used graphing, and now we're using something.
Why wouldn't we want to graph this? Yeah, I could graph this one, sure. This top one, I don't want to graph 144. I don't want to do that, all right? So all you're doing, for example, 1e is writing this, if you haven't already. Okay, so,
Wish I could.
someone tell me what, Madison, what am I gonna do first?
First you're gonna put parentheses around before the equal sign on the first one.
First one or second one?
The second one.
Second one.
And then the y.
Why the second one?
Because that's the one where the y
Yeah,
is.
y is by itself, right? And then you said, what else am I gonna do?
Put parentheses around the y.
In the other one. Excellent, very good. So I'm gonna put parentheses around y. I think Mr. Hager's gonna do that.
Whoa.
He's gonna put parentheses around y in the other one. All right? So it's gonna take and put parentheses around. Now, this one's a little bit different because example, I think it was 1a and 1b, the top equation was isolated and the bottom was not. This is just a little different. It could be different. It could be different. You could have, like I said, you could have both that are isolated. So I'm going to take this. I'm going to plug in for y. All right. So Jack, now I actually want to set it up, right? So tell me what to write. I'm taking the bottom and plugging. I'm taking equation 2, information from equation 2, and plugging into equation 1.
Oh, wait. I'm tired.
So what's the first thing written in equation 1? The top one. What's the first thing written in equation 1? What's the first thing? Look. Jack, look at this. Look right here. What's the first thing written? What's the first thing written? On the board. Here's example 1. I mean, here's equation 1. What's the first thing written? 4x, right? I'm going to start with 4x. Sorry, Mr. Hager. I'm going to start with 4x. All right? Sophia, what's the next thing written after that?
Plus 6.
Plus 6. All right? Then, what am I going to write? Someone tell me by raising their hand. Josiah. Parenthesis.
Just 4 plus x.
4 plus x.
Parenthesis.
Yeah? Want to finish it off? Equals 144. Mr. Hager, are we okay so far? Okay. Good? So now I'm into the part where I have to solve, right? So someone, how about Sydney? What do I have to do first in this part? If I'm looking at this right, if I was going to solve this equation, what would I do first? Yeah, what does that mean? What do I have to do? I got to take something from the outside and bring it in the inside. What do we call that? Starts with a D. And what math operation is that? Good. So what number am I going to distribute? 6. Positive or negative? Positive. Right? I'm going to distribute the 6 into the 4 and into the x. Alright? What happens to the 4x? Just bring it down, right? There's nothing to change it. 4x. Now, when I distribute the first thing, x, when I distribute the first thing, this to that, what am I going to get? Positive or negative? Positive. I got to make sure I put the plus so I know. Plus 24. When I distribute the second thing, when I distribute the second thing, so I did positive 6 times positive 4, I got positive 24. Now I'm going to distribute to the second thing. What will I get?
What? The second one?
Yeah.
I'm just going to get regular 6.
So I'll get positive 6x.
Yes.
Right? Because there's a 1, this is a 1x. 6 times 1 is 6, and I just put the x with it. Right? And that equals 144.
Is that a plus or a minus?
Where? This is a plus. I'm sorry. That's a plus.
Oh wait.
Okay, now, next, what do I have to do?
Combine like terms.
Combine like terms. Savannah, what are my like terms? And tell me if they're positive or negative.
5 minutes.
Positive 4x
No, 1 minute.
and 6.
Yeah, when you combine those two things, Savannah, what do you get? 10x. I combine them, I get 10x. Bring the plus 24 down, equals 144. All right? Now, Jenny, what do you want to do?
Add or subtract.
What do you want to, are you going to add or subtract in this problem? Look what you have left. Subtract what number?
24.
Perfect. So when I do that, I get 10x equals 4 minus 4, 0, 4 minus 2, 2, and just bring the 1 down. Last step, Mallory?
Divide by 10.
Divide by 10. Excellent. X equals what? X equals what? 12. What do I do?
You plug in.
Top or bottom?
Bottom.
Bottom. Why?
Because it's easy.
And it's already, that's all that's y isolated. So it's going to become y equals, tell me what to do, guys.
4 plus 12.
4 plus 12.
Which is
Y equals
16.
16. How do I have to write it? Tell me what it is. What's the coordinate? 12, comma, 16. Here's your answer. All right.
Y equals 4.
Oh, no, I'm sorry. X was what? Smaller or larger? Smaller candles or larger candles? X. So we say it was smaller or larger? The candles. Smaller, right? So we sold 12 small and 16 large. That's how we do that. All right, so 12 small, 16 large. All right? Don't worry, guys. Savannah will be back. It's okay.
I thought it was for me. It usually is for me.
All right. So, does everybody have
You
this?
can ask her every time I.
Does everybody have this?
It's for me.
Everybody has this. So, a couple things.
Please, I can.
Yeah.
Yeah.
So I'll leave that. I just want to go over this quickly, right? Homework. I'll give that to you guys in a second. Don't worry about this, guys. I don't know why that's on. I don't know why that's on there. All right.
What are the variables? What's the
Don't worry
column?
about this. Don't worry about this. I don't know why that showed up on there. I thought I changed it. Remember, guys, tomorrow. All right. We have the guest speaker. All right. So we'll have like maybe 30 minutes of class. All we're gonna do is just work on review stuff. Nothing new tomorrow. And then the second half of section 5.2 we'll do on Thursday. All right. And then you guys have a test on Friday.